Hi, and welcome to this PySQL class. In this video, we're going to provide an overview of the PySQL family, what the products are, what their data flows are. The goal of this video is to provide guidance on this diagram. This diagram shows all the current products and their data flows. As somebody who's going to be developing with the PySQL products, it's important to know what your options are. In order to understand this, as it's a little complicated, I find the best way to describe it is to go through a history of the PySQL family and to see what the landscape looked like at the release of each product, and it'll provide a little bit of guidance on why they were released. We'll start from the beginning, when the PyData archive was connected to by client applications using the PyAPI. This required that the applications were natively built against the PyAPI to connect directly to the PyData archive. This posed a problem whenever you're trying to use an application that uses things like ODBC data sources. ODBC is the Open Database Connectivity Standard, which allows for one application to use this ODBC interface to connect to multiple different ODBC data sources, or even just one that they don't want to write native code against. So, in 1998, OSIsoft released the PyODBC client to expose the PyData archive as an ODBC data source. This used the 2.x ODBC API, hence the 2.x above the little box. And as you can see in the legend, I'm trying to make it a little bit obvious on what the endpoints are and the connectivities of everything by having circles for native Py connections. As you can see, this is the smoothest and most efficient way to communicate. And then a little box for ODBC. This is a little bit, boxier and not as fine-tuned for one specific data source, but it still very much gets the job done. The PyODBC client utilizes the PySQL subsystem on the PyData archive for all of its query parsing. The application will write a SQL query. The PyODBC client will send it over to the PySQL subsystem, and the PySQL subsystem will parse it into the data that it needs from the PyData archive, whether the snapshot subsystem or the base subsystem or the archive subsystem, etc. Then it'll send it back to the client, and then the ODBC client will provide the connectivity to the application to get the result set. In 1996, Microsoft introduced the OLEDB standard that expands upon ODBC. As you can see from my little symbol, the OLEDB protocol has a little bit more to it than just the ODBC. That's a good way to think about it because it expands on the functionality, but it's effectively the same thing. There's things like metadata that is provided with OLEDB that is not provided with ODBC. So in 2001, in response to this, the PyOLEDB provider is released. This exposes the Pi server as an OLEDB data source. The PyOLEDB provider also moves the query parsing off of the PyData archive. This allows the client architecture to absorb some of the processing requirements and allow the PyData archive to focus on other things. This allows for higher throughput of, let's say, snapshot updates, because the PyData archive is not doing things such as PySQL subsystem query parsing, but the client is doing that and simply communicating with the PySDK. In 2010, the JDBC driver was introduced for Java applications. As you can see from the symbol that I use for JDBC, it's a lot like the ODBC, but a little bit different. It's coming from Java applications. JDBC is an integral part of Java runtime environments, so any Java application or any Java development that you're going to do will inherently allow JDBC connections. Since this change for the PyJDBC driver is only a change in endpoint from OLEDB or ODBC to JDBC, we decided not to rewrite any of the query parsing itself and to simply provide the JDBC driver with a way to access the PyOLEDB provider. This way, all the queries that you could write for the PyOLEDB provider in an OLEDB application can be written in JDBC as well. To do this, we introduced the PySQL Data Access Server. This, as shown here in the diagram, provides a secure channel using either HTTP or NetTCP, and it passes the JDBC query from the client application to the PyOLEDB provider. Then the PyOLEDB provider will speak to the PyData archive on its behalf. When the results come back, the PySQL Data Access Server will provide the result sets back to the PyJDBC driver and the Java application. In 2014, we introduced a 3.x ODBC driver. This uses the same data flow as PyJDBC, again, to make sure that we don't replicate any form of development and have the same code written multiple times, that kind of thing. Now, the same query parsing can be done through 3 different endpoints: OLEDB, JDBC, and ODBC. In 2007, the AF server was released, but the PyOLEDB provider cannot connect with it because it's using PySDK. This posed a problem for our customers, as there is data on the AF server that you would like to query from your OLEDB application, your JDBC application, or ODBC application. So in response to this, in 2010, we introduced a new OLEDB provider for exposing AF servers, the PyOLEDB Enterprise. This name can be a little bit confusing because it is itself an OLEDB provider. However, we already have a product called the PyOLEDB provider. The name PyOLEDB Enterprise also reinforces the idea that AF, and therefore this OLEDB provider, is an enterprise-wide solution for your data. If you're struggling to remember which one is the PyOLEDB provider and which one is the PyOLEDB Enterprise, just remember that the PyData Archive came before the AF server, and clearly the PyOLEDB provider was the first OLEDB provider for Pi. Therefore, the PyOLEDB provider must expose the PyData Archive, and PyOLEDB Enterprise exposes the AF server. Now, the data flow of the PyOLEDB Enterprise is similar to any other AF SDK application. You have an AF SDK connection to the AF server, to the AF application service. The AF application service then makes a SQL native client connection to the SQL server hosting the PyFT database. To resolve any PyPoint data references, the AF SDK client itself, in this case PyOLEDB Enterprise, makes an AF SDK connection to the PyData Archive to resolve those. Now, this led to an interesting problem that some applications, such as the Microsoft SQL Server, cannot use OLEDB providers that have .NET code. This query engine uses the AF SDK, which is itself a .NET library. That means that because the query engine is on the client and the PyOLEDB Enterprise requires an AF SDK, therefore .NET connection, the Microsoft SQL Server, among other applications, are going to have to load OLEDB providers with .NET code. Since this does not work, in the first release of the PyOLEDB Enterprise, you could not make an in-process link server with the Microsoft SQL Server. We'll go over what that means in a little bit if you don't already know. But what this led to in 2011 was the introduction of the PyOLEDB Enterprise Agent Service. This decoupled the OLEDB endpoint from the query engine and therefore AF SDK calls. This means that the process space of the Microsoft SQL Server process does not need to include the AF SDK or any .NET libraries. The OLEDB endpoint itself is COM, therefore everything is separated as necessary. The PyOLEDB Enterprise Agent is a different process that itself can host the AF SDK and be the AF client. So that leads us to an overview of the 2011 through 2018 PySQL family overview. Over those years, we've released new versions of everything, but we didn't make any landscape-wide changes to any of the products or their data flows. So we'll go through the data flows one more time just to make sure that everything is understood. So if you're using a 2.x ODBC application connecting to the data archive, it would look something like this. PyODBC client connecting with it PyAPI to the PySQL subsystem. If you're using an OLEDB application direct to the PyData archive, you'd be using the PyOLEDB provider to use PySDK to talk to the data archive. OLEDB application to the AF server would use PyOLEDB Enterprise going through the PyOLEDB Enterprise Agent Service to talk to the AF server and the PyData archive. You can optionally turn off the PyOLEDB Enterprise Agent Service if you would like to, and if your application allows it, and your data flow looks like this. For 3.x ODBC applications talking directly to the data archive, you have this data flow. It goes from the PyODBC driver to the PySQL Data Access Server, which will then use the PyOLEDB provider, and then it will speak PySDK to the data archive. JDBC is the same thing, but with the JDBC driver and a Java application. For an ODBC application connecting to the AF server, it would use the PySQL Data Access Server to communicate to the PyOLDB Enterprise, which would then use PyOLDB Enterprise Agent to connect to the AF server and data archive. Same thing with the JDBC driver, except that it's using the JDBC driver instead of the ODBC driver. In 2018, we released a new product called the PySQL Data Access Server RTQP, or Real-Time Query Processing. This new query engine sits on the AF server itself and uses SQL Native Client to speak directly to the SQL server that hosts the PyFD. Clients use the OLDB, ODBC, or JDBC endpoints just like before to communicate to the PySQL DOS. This data flow is similar to the ODBC driver and JDBC driver from earlier. However, the communication with the PySQL DOS is substantially simplified, as you can see from the diagrams on the left versus diagrams on the right. This change also allows the OLDB endpoints to be decoupled from the query processor. This is something that the ODBC and JDBC drivers could do. However, the OLDB endpoints, given that they were connected to the query processing for PyOLDB Provider and PyOLDB Enterprise, had to reside on the same machine for the application and the query processing. With PySQL DOS RTQP, we no longer have to do that for OLDB applications. This completes our walkthrough of the diagram that we showed at the beginning of the video. Hopefully by this time, you have a little bit of understanding of what the products are, what their data flows are, and we can start to go over the implications of which ones to use in certain scenarios, which we'll do in the next video. Thank you.